you said, do you like still learn things about it, or?
Oh, absolutely, absolutely, without a doubt. The field is forever changing, and you have to change with it because technology changes, and if you don't change with it, you kind of get buried. So you have to continue your education. Now, not to say that you have to sit in class and do things like that, but as technology changes, you have to grow with it. And here's where...
Can you talk a little bit about the NEC, like the code, like how you have to stay on top of that?
Well, sure, yeah, the code, what they do with the code changes every 3 years. There's a new code book every 3 years, and what they do with the code book is they actually do whole classes on the changes that were made from like 90, well, what's the last code? It was 11, I guess, or 12 maybe. 2012 or 2000, yeah, it would have been 11, 2008, 2012, or 11. But what they will do then is there's courses that you can take that will actually go over all the changes that have taken place over those previous 3 years. So they make the book, and a lot of times they're amended due to change in industry. The biggest change in our industry, we don't really do a lot of it, is solar energy. So as far as the code was concerned, you know, it's fairly new to the industry. There's a lot of hurdles that they went through. There's some things that they knew up front that they had to introduce into the code as far as requirements. And that's an aspect that is changing and growing and evolving. So as that grows and as that changes with products and different installation practices and stuff like that, they will amend the NEC to that level. Now, keep in mind, the NEC is a minimum requirement. So you might get into jobs like we do a lot of jobs that are engineered projects that might be beyond what is the minimum in the code book, which is okay. You can exceed that. You just cannot, you basically have to do that at a minimum, which I shouldn't say it's like at a lower tier. It's not really at a lower tier, but that's, you can obviously improve upon some of those aspects. And industry, as far as changes, like actually a thing that I was just exposed to 2 weeks ago. I was working on a machine in Willow Street, and we used a relay that actually had diodes in it, which would only allow electric current to flow one direction. I don't know if you've even touched on that at all. And it was an Allen Bradley part, and it was used in combination with another part. Well, that other part needed resistance to work. And their engineers at Allen Bradley, we kind of figured it out in the field that we actually had to put a resistor in parallel with the relay. This might be a little bit over your head, but we had to put a resistor in parallel with the relay to make it function. And so we were kind of working between us and the plant down there in Willow Street and engineers from Allen Bradley as why this part didn't work or why it didn't function the way it should. And that was their remedy. There was no real written remedy. There was one engineer that had some notes written, and this is how it worked. But now, through that process, they're going to have to amend their, what they call an SOP, which is a standard operating procedure.
Oh, guys, where'd you hear that before?
So what'll end up happening is that procedure will have to be written into their rules and regulations, so to speak, that if this part is used with this part, you need this application to make it function properly. So things are forever changing, and sometimes you will discover problems in the field that maybe an engineer didn't think of or didn't run into, or I don't know how else to really put that into words, but sometimes you will stumble upon things like that. So that's why, out of 25 years of doing it, always ask the question. It doesn't matter how simple it might be, just ask the question, because if you left it unasked and go through a situation and then the end product ends up being a problem, that's why it's simple. And even as an apprentice to a journeyman, don't ever feel just because you're the apprentice that you can't ask your peer, is this the right way to do it, just because they told you to do it that way or this, whatever. Don't ever feel bad about asking a question. Sometimes it might ruffle their feathers a little bit, but I mean, bring things to the table. At least in my personal experience, I would sooner have someone come to me with a question, and I can either well, one, I'll listen to the question no matter what, but give them the answer of why I want it done a specific way. And if they would actually have a good reason of why, well, then I'll say, well, yeah, that is a pretty good idea. We could do it that way.
It would be how they approach you, though. They wouldn't, again, it has to do with how they present their questions to you.
Yeah.
So you can't say you're wrong.
Yes, yeah, you don't want to right off the cuff say that, you know, this is this isn't going to work and why, you just bring it up or kind of put the ball in their court and ask the question. Because experience, sometimes you can't always get everything out of the textbook. And there's a lot of things that are learned in the field and in the trade. It doesn't matter what trade and in what aspect of business. When you have someone that's in the field for 20, 30 years, you pick up on things, maybe a quicker way to do it or an easier way to do it on that aspect of it. So you always want to have open ears. So, I mean,
can you touch a little bit on LED? Like, what are your thoughts on LEDs? Like some of that energy savings. Obviously, solar's big. Like, do you guys have issues with them, or do you use them a lot in your practice?
We do, and there's another issue where industry, as far as the LED, which is the light emitting diode, technology has surpassed some of the components that you're using it with. You look at dimmers in your house. We ran into this was an electronic dimmer, and here again it needs resistance to function properly. The LED light bulbs do not sometimes generate enough resistance to make that dimmer function properly, or you actually have the dimmer off but the lights are just barely lit because it allows enough redundant voltage to pass through the switch, whether through capacitance or whatever, but the resistance of the light bulb, of the LED, there's not enough resistance there because it's so small as far as the load. Because you look at a regular 60-watt light bulb, okay, and then you have an LED light bulb that might be comparable in the same amount of light output, but might only be 5 watts. So you have 60 watts versus 5 watts. That's what I'm calling resistance. And sometimes the way things were designed is designed off of resistance. And you have some analog or digital meters there and some analog meters. Don't ever, like in my trade, we have digital meters, and I tell some of our younger guys, don't always rely on the digital meter because your analog meter has resistance to it. So sometimes you can, like I have a fluke meter that I use 99% of the time, but sometimes if you get stray voltages or capacitance in a line, you can actually read voltage that's there, but it's truly not there. Like your digital meter doesn't have enough resistance there to make it disappear. And I don't know how to really explain that to you other than experience, but if you would use a analog meter which actually has more resistance to it when you it's not a usable voltage. Like in other words, you could physically go up and touch it and you won't get shot. But on your digital meter, it could say that there's 90 volts there or 80 volts there or something like that, just because the meter is that sensitive, it actually sees it.